Welcome to The Explainer. Today, we're diving into a thought experiment that is a total mind bender. It's a puzzle that seems so simple at first, but trust me, it pulls you down a rabbit hole into probability, what it means to have evidence, and even the nature of reality itself. So here it is, the core of this whole mystery. You've got Sleeping Beauty, a coin flip, and a simple question. When she wakes up, what's the probability the coin landed on heads? The answer seems like it should be totally obvious, but as you're about to see, it is anything but. Okay, before we can even try to get our heads around this, we have to get the rules of the game straight. The setup here is incredibly specific, and every little detail really matters. All right, so let's walk through this. It all kicks off on Sunday. Someone tosses a completely fair 50-50 coin. Now, if it comes up heads, Sleeping Beauty gets woken up just once, on Monday. Simple enough. But if it's tails, she's woken up twice. First on Monday, and then again on Tuesday. And here's the kicker, the part that makes this whole thing so tricky, that amnesia rule. Every single time they wake her up, they give her a drug that erases the memory of that awakening. So from her perspective, every time she opens her eyes, it feels like the very first time. She knows all these rules going in, but when she's awake, she has no idea if it's Monday or Tuesday, or if she's been woken up before. So let's start with what feels like the most obvious answer, right? This is the Hafer position, and it's where most people land when they first hear about this problem. And their thinking, which was really championed by the philosopher David Lewis, goes something like this. Look, she knew it was a fair coin on Sunday. Waking up doesn't magically change the physics of the coin. She hasn't learned any new information that's actually relevant to the coin toss itself. For a Helfer, this is all that matters. The whole setup with the waking and the amnesia, that's just window dressing. The fundamental probability of that coin is and always will be 50-50. It was 50-50 before she went to sleep, so it has to be 50-50 when she wakes up. Case closed, right? Well, not so fast. Just when it seems like the answer is settled, a totally different perspective comes along and flips the entire problem on its head. This is what's known as the thirder position. And this is where things get really fascinating. It all hinges on this idea of a self-locating belief. Thirders argue that this puzzle isn't just about some external thing like a coin. It's about Sleeping Beauty's uncertainty about her own position in time. The new information she gets isn't about the coin. It's the simple fact that I am awake right now. And that, they say, changes everything. The philosopher Adam Elga really pushed this idea. He basically said, hang on, we're counting the wrong thing. We shouldn't be counting the outcomes of the coin toss. We should be counting the number of possible, distinct awakening experiences she could be having right now. From her point of view, any of them are equally likely. And this chart lays it out perfectly. There are 3 possible scenarios she could find herself in. 1, the coin was heads and it's Monday. 2, the coin was tails and it's Monday. Or 3, the coin was tails and it's Tuesday. She has no way to tell them apart. So, since only one of those 3 equally likely possibilities happens on a heads result, her confidence that the coin was heads should be 1/3. Okay, so now we have 2 camps, right? The Hafers and the thirders. Both of their arguments sound pretty logical, but they can't both be right. So let's put them side by side and see exactly where they clash. This table just cuts right to the heart of it. On one side, you've got the Hafer view, saying the coin's probability is a fixed fact about the world, and waking up tells you nothing new about that. On the other side, the thirder view says, no, the awakening itself is a new piece of evidence. They're disagreeing on the most fundamental level about what even counts as evidence. Is it just objective facts about the world, or does your own subjective experience of being awake now count too? Now, I know what you might be thinking. Okay, this is a fun little puzzle, but who really cares? Well, it turns out this isn't just a brain teaser for philosophers. The answer you choose has some surprisingly massive consequences for some of the biggest ideas in science. You see, how you answer this little puzzle has huge ripple effects. It plugs directly into something called anthropic reasoning, which is really just a fancy way of asking, how should the fact that we exist to observe the universe affect our theories about the universe? For example, if you're a thirder, you might be more friendly to theories like the quantum many-worlds interpretation. Why? Because if there are way more possible tails awakenings, maybe we should favor theories that predict a greater number of total observers overall. Your answer here isn't just a random guess. It's a reflection of how you think we should weigh evidence about the fundamental nature of reality. So where does that leave us? Well, after decades and decades of brilliant people arguing about this, the truth is, they're still arguing. There is absolutely no consensus among philosophers or statisticians. The mystery endures. So, at the end of the day, it really just boils down to this. The halfer, who says you stick to the objective odds of the coin, and the thirder, who says your own subjective experience of being awake is new information that you have to factor in. Two perfectly logical paths that lead to two completely different destinations. And that brings us to one last, really fascinating thought to leave you with. Imagine you actually ran this experiment 1,000,000 times. What would the data show? Well, you'd find that awakenings on tails days happened about twice as often as awakenings on heads days. For thirders, that settles it. But for halfers, it doesn't. And that just leaves us with the biggest question of all. What is it about this one seemingly simple problem that our logic just can't seem to crack?